Okay, ladies and gentlemen, welcome to today's class. And today we're still solving triangles, but we are using more of an application step. So we're going to see at least two story problems, one or two story problems on how you would apply what we've been doing with solving right triangles to real world applications. And I'm actually going to start with problem number. Or example, excuse me, example number 5, which is on page 50 of your textbooks. And I'm actually going to, page 49 of your textbooks, excuse me. So I'm actually going to go ahead and read the problem to you and explain some of the things that we're going to be doing and hopefully be able to explain this. And then we'll have another story problem that you guys can work with real quick. Okay. So the story problem reads, it says in this picture, and of course you have to follow the picture on page 49, you have, excuse me, in this picture, car 19 is behind car 2. If the angle of depression is 18 degrees from car 19's driver's eyes to the bottom of the 3-foot back end of car 2, how far apart are the bumpers? Assume the car's horizontal distance from car 19's driver's eyes from his car is 5 feet. So first of all, let's talk real quick about what this means. Now, in a car, specifically in a race car environment, now this is my take on cars. I know it's like a kindergarten drawing, but hopefully the concept will come across. A person sees three things. So, one, if the person is in front of the car, everything that he sees up is what we call the angle of elevation. What he sees straight ahead is what we call the horizontal. And what he sees downward is what we call the angle of depression. Now, this story problem, just like all story problems, has some information. Now, the first thing that they're telling us is the angle of depression. So here, I drew car 19 behind car number 2, and the angle of depression, which is right here, is 18 degrees. And it says the back end of car 2, and this would be car 2, and let me label it. I mean, well, box 2, because it doesn't really look like a car, but the back end is 3 feet, and which is what I wrote down here. And then they want us to, and the distance from the, it says the distance from the driver's eye to the front of car 19 is 5 feet. Okay, so what I did was I took this and I drew it here. So the 3, which is what's down here, represents the 3-foot back end of car number 2. The angle of depression is basically, so the angle of depression is 18 degrees, and that means that he's kind of looking at the back end of the car 2's bumper at an 18-degree angle. And of course, what he sees straight ahead is the horizontal, so we labeled it as X. Now, if I want to know the distance between the bumpers, the first thing I need to understand is that the what the driver sees from his vantage point up to the front of the car is 5 feet, and I don't know the horizontal. So I need to find the horizontal and then subtract that. So to find the horizontal, I have 3 feet and I have 18, and I'm missing this side, the horizontal side. So if I look at the horizontal is adjacent to 18 degrees and the 3 is opposite. So opposite of adjacent means tangent. So I'm going to say the tangent of 18 degrees is equals the opposite, which would be 3, over the adjacent, which would be X, which is what I'm looking for. Okay, so what you guys can do is on your calculators, you can look for the tangent of 18 degrees. And the tangent of 18 degrees, guys, is, one second. The tangent of 18 degrees is 0.3249. So let me just write this. Let me write it down here. Let me write it as a text box. It's easier. So the tangent of 18 degrees is 0.3249. 0.3249. 49 0.3249 1969 696. Okay, 696. And that's going to equal to, and that's going to equal to 3 over x. So we can solve this like I did before in class, either, algebraically or via proportion. I like to do it via proportion just because there is an equal sign. So the tangent of 18 degrees is 3 over x. And what I do next is I simply write this as a proportion and over 1. So obviously, if I multiply 0.3293249196996 times x, which is what I'm going to do here, that's going to equal to, give me 1 second, guys. If I multiply that, that's going to be 0.32 49 19 696 x, because we multiplied it by x. Okay, and of course 3 times 1 is 3, so you just say equals 3, because you cross multiply 3 times 1, so we say equals 3. And what we do is we divide each side by the tangent of 18, which is 0.32 3249 19596. 19696, excuse me. 696. And we do the same thing on this side. And that'd be 0.32 4919. Um 19696. So you divide this, obviously, this side cancels out. And x is going to be approximately 9.23, more or less. And I need to take into account my significant digits. And I know that, for example, 18 has 2 significant digits and 3 has 1, but we're always going to leave our answer expressed to the least, equal to the same amount of significant digits as the lowest one. In other words, 3 is 1 significant digit, 18 is 2 significant digits, so I'm going to round my answer to 1 significant digit. And since next to the 9 there's a 2, I leave it expressed as x is approximately 9 feet. So then we're still not done, because all I know is that the horizontal distance is 9 feet. But I still need to find how far the bumpers are. And it says the distance from the driver's eyes to the front of the car is 5 feet. So if the horizontal is 9, I have to subtract the 9 minus the 5 feet that the driver's that which is the distance of the driver to the front of his car, and that would be 4 feet. So the bumpers are actually approximately 4 feet apart. Okay, so that's one of the applications that we have for this. I'm going to do one more, and then that will be the end of this video lesson for you guys. So actually, I'm going to go ahead and let you guys take a look at that real quick. Then I'm going to simply just delete it, and we'll start with the next example real quick. So I'm going to go ahead and delete all this. And now we're going to look on page 50. I believe this is example number 6, and it is another story problem. And we have to be careful, and a good strategy when working with story problems is to definitely read it more than once, because there's always a piece of information that is either necessary or sometimes unnecessary. And example number 6 says, assume that the International Space Station, which is ISS, and it says, which is 108 meters long, and 73 meters wide. And that's like, it's in parentheses, it's like some added information. Is in a 400-kilometer low Earth orbit. Is in a 400-kilometer low Earth orbit. If the communications antennas have a 1-minute pointing error, it says how many meters off will the communications line be? Okay, so it says, and let me see if I can move this over here. It says, assume that the International Space Station, which is 108 meters long and 73 meters wide, is in a 400 kilometer, give me 1 second, guys, is in a 400 kilometer low Earth orbit. Low Earth orbit. So we're talking about the International Space Station. We're talking about the fact that it's in a low Earth orbit. Okay. And there's also saying if the antenna is or are pointing in 1 minute measuring error. Okay. So let me explain that to you guys real quick, because I know it sounds kind of confusing, but it's actually a lot simpler than the problem makes it out to be. Okay, so here we go. Okay, pardon the noise, I've been moving some things around. So once again, it says, assume that the International Space Station, which is 108 meters long and 73 meters wide, is 400 kilometers in a low Earth orbit. I forgot to write the word in, so give me 1 second. In a low Earth orbit. If the communication antennas have a 1 minute pointing error, how many meters off will the antenna be? So here's the thing that we want to note of the problem. And It is to point out the information that we do have, okay? And in this case, the way that we do that is by drawing a triangle. Now, we're talking about an antenna in a, let's see if I can draw an antenna-like figure or a satellite-like figure. Let's say that the satellite is pointing here, and it's saying that the International Space Station is 400 kilometers. So I'm going to draw like a box, a rectangle, because I'm good at drawing rectangles. And that is going to be my International Space Station. And we know that it's 400 kilometers away. So again, 400 kilometers, which is here. And it says that there is a 1 minute pointing error. Okay, so remember that we have angles in degrees, minutes, seconds. So they're actually giving us our angle, but they're not giving our angle. They're not giving it, are giving us the angle in DD or decimal degrees. They're giving it to us in degrees, minutes, and seconds. So basically, we have ourselves a right triangle. Of course, we have our 90-degree angle here. And they want to know how many meters off. So what they need to do is basically just find the hypotenuse in this case. Okay, why the hypotenuse? Well, because we have the 400 kilometers, which is the distance, and we have, let me see if I can draw this or change the color of the one so it doesn't look like a blob. This is actually 1 minute. Okay, so give me 1 second. Let's see, this is actually one, and then of course that little comma, which is the minute. So the first thing I need to do is, well, what I'm looking for is this. Or excuse me, I wrote it in the wrong place. What I want to know, according to the problem, is how many meters off will the communications line be? So there is an error here because it's 1 minute off. So that means that the space station is here. So there's an error here. So I want to know how many meters will this error be. So I have my opposite because, of course, it's 1 minute behind, and I have my adjacent. So I know that I'm going to use tangent. And I'm going to use the tangent of 1 minute. Tangent of 1 minute equals the opposite, which is x, over the adjacent, which is 400. Now, you need your calculator, but there is no way your calculator can give you the tangent of 1 minute, which means I have to take this 1 minute and convert it into decimal degree. So the first step is to take the 1 minute and divide it over 60. So we're going to divide 1 over 60 to find or 1 minute over 60, because remember that 1 minute is 1/60th of a degree, and we're going to divide that to get our answer in decimal degrees. So our answer in decimal degrees is actually 0 point, and I'm going to write it down here, 0.016. 6, and we have 6 sixes, 7. Of course, equals x over 400. So we're going to cross multiply, guys. Remember, I mean, you can do it algebraically, and eventually you're going to get, and then you're going to get the same answer. Because there's an equal sign, I like to use the proportions button. So I'm just going to say over 1. And we're going to cross multiply. And we're going to say x times 1 is x. And then we're going to multiply the tangent of 0. Let me actually erase this. Give me 1 second, guys. Let's see if I can erase this. Okay, so let me see if, let me try that again. Nope, doesn't let me. Let's see, I'll get it. Yeah. This is an interesting video. All right, I got it. So let me just write the 1 over 60 over here so that it doesn't get a little confusing. So this will be our last one. So 1 over 60. And we said that was approximately, let me text it here because it's easier. 0.0 1 6 6 6 6 6 6 7. Okay, so and here now what we need to find is the tangent. So this looks better labeled, or we have the tangent, excuse me. Okay, so we have to find the tangent of 0.016666. Okay, so again, the first thing I did was I converted the 1 minute into tangent, into decimal degrees, and I divided that 1 by 60, which is what I've got right here. And now I need to find the tangent of that number and multiply it by 400. So I take x times 1 is x, which is pretty safe to say. And then what you guys are going to do is just find the tangent and multiply that tangent by 400 degrees. And when you multiply that by 400 degrees, or 400 kilometers, excuse me, not 400 degrees, the answer that you guys get is 0. Let me text it in a box. 0.1 6355. But our answer is given to us in kilometers. So that means that we need to turn that into meters. Okay, so we have our answer given to us as in kilometers, and we need to actually turn that into meters. So remember, basically, what we're going to do to this final answer is multiply it by 1,000, because remember, 1 kilometer has 1,000 meters. So I'm going to take this answer and I'm going to multiply it by 1,000. And remember, guys, that 1,000, that 1 meter, or that 1 kilometer is 1,000 meters. So basically, if you guys want to review what we did in chemistry, we're reviewing the conversion factors. Okay, so remember that 1 kilometer is 1,000 meters, and we're gonna multiply this number 0.116355 by 1,000 so we can have our answer in meters. And remember that we need 3 significant digits. Why do we need 3 significant digits? Well, because if I look at the degree, there are 7 significant digits, and 400 has 3 significant digits. And I always leave my answer rounded to have the same significant digits as the number with the least amount of significant digits, which in other words means is 0.01666667 has like 6 or 7 significant figures, and 400 only has 3, or only 3, because remember the decimal point, just like in chemistry, 3 significant digits. We're going to leave our answer expressed at 3 significant digits, which would be 116 meters. So our answer is 116 meters. So in reality, x equals 116 meters. Okay, so this is the end of this video lesson, guys. Hopefully this is helpful. If you have any ideas or questions that you'd like to ask me, you know where to find me. So stay safe, and we'll see each other in our next class.